bit left. In this chapter, we're going to look at neurons and how they work, and let's see a little bit more about the body as a conductor. Last time at the very end of class, I think we looked at the E-meter. I showed you the video, but let me just tell you a little bit about it. Um, Now, Scientologists, they sort of take the E-meter as a spiritual tool or something. I don't fully understand exactly how they use the E-meter, but it is fairly interesting to think about how it measures the resistance of your body and uses that to figure out when your body is responding to something. You remember the video we watched at the very end of class last time? It was like it was like 60 minutes, and you hold these two cans or whatever, and they send a current through your body. So one of them, you have a current that runs through your arms and goes to the other side. And what it does is it measures the resistance of your body. So this E-meter, that's what they call it, sends a current through your body, a very small current, and measures the resistance of your body. The resistance is affected by a number of things. Your resistance can be affected by water on your palms, right? If your hands became wet, what would that do to your resistance? Would it cause it to go up or down? It would go down, right? You would become less resistant to the flow of electricity. You can also see the effects of changes in blood pressure. If your blood pressure goes up or down, it can affect the resistance of your body, or also changes in body chemistry can actually affect the resistance of your body. So it's actually a pretty cool device, apart from the, I don't know, whatever the purpose they use it for, but it can detect when you have changes in your body that might be due to something that you're thinking about or something that your body is going through at the time. Right. They use it in a psychological sense. So like when you think about things that are traumatic to you, then it will cause a change in your body that will re-registered on this e-meter. When we go over to the rec center, if they allow us, we'll look at something else that does something similar but a lot different. It's called the direct segmental multi-frequency. It's the body scan 230. That's, you guys might have one back in athletic training. Do you guys have one of these? It's one of these devices where you stand on it and you hold the handholds, and then it produces a report of your body mass and how much water you have in your body and all that business. You ever seen one of these? Yeah, we'll take a look when we go over to the rec center on the last day of class. We'll take a look at this, and maybe one or two of you can actually do a body report. This is called the direct segmental. I'll describe what these terms mean. Segmental, um, multi-frequency bioimpedance. It's a mouthful. Analysis. Listen, back in the 60s or so, they determined that the amount of water that you have in your body is directly related to the resistance of your body. And so if you have more or less water, it will affect the resistance of your body. And so they started measuring the resistance of your body. They would run a small current from your head down to your feet. And when they measured your overall body resistance, they had these tables they could go through and say, okay, you have this much water in your body. And then that could go further to tell you, based on measurements of weight and height, what is your muscle mass, what is your bone mass, stuff like that. So um, the device looks something like this. You have a table that you stand on, and there's a little thing that comes up that comes down, and then you stand, like this, and you grab on, those are your hands, grab onto these two handholds that will send a current through your hands, up through your body, and then they go down out through your feet. So when you stand on it, and we'll see it later in the semester, you'll actually take your socks and shoes off, and you take some wet wipes and make the bottoms of your feet wet. You spit on your hands, and you grab the things so you don't spit on them. You wipe your hands with these wet wipes and grab the handhold. So you get good connections, and it sends this very small current through your body. And then it measures your bioimpedance. That's just a fancy word for what? To impede something is to do what? If you impede something, right, you stop it or you slow it down. So this is really just a fancy word for your body's resistance. This word just means your body's bio electrical resistance. So in the early days of these studies in the 60s and 70s, they would just have this very simple thing. They'd run a single current through your body, and then they'd measure your resistance, very much like the e-meter that the Scientologists use. Now they do different things where they actually run electricity at multiple frequencies, right? We talked about frequencies and what that means. So you have waves of sort, these electrical signals that are going through at multiple frequencies. And what that does is it allows uh, the electrical signal travels through different parts of the body. Well, ladies? It gives you a better analysis of what your body is like because electricity is going to flow through your trunk in a different way than it flows through your limbs. Right? And so they have these multiple frequencies of these electrical signals that will give you a better analysis of different parts of your body. So that's what this multi-frequency means. And it's also further linked to this segmental, that it breaks your body into segments. Let me show you what I did this a couple of years ago, this body scan 230 over the rec center. As students, you can use it. I think they charge a fee, but usually if you just ask them, they say, okay, you can use it. But I just did it for this class a couple of years ago. Can I take this down, Joe? All right, let me pull it up. Let's see, this was from September of 2014. So gives my age there, my height. This was, as I said, in September of 2014, and then it gives the all the values for gives the value for my total body water. So by this measurement of resistance, it says I have about 102 pounds of total body water, 36 pounds of lean mass, and then about 15 pounds of body fat. Give me a total weight of about 152 pounds at the time. Gives my weight there, gives my skeletal muscle mass and my body fat mass, various. This is my BMI. This is where the segmental analysis, so it tells me how much mass. This isn't me, by the way. This is just like a picture of a guy. It gives the amount of muscle mass that I have on different limbs. So because they have these multiple frequencies, they can analyze the different parts of you. So for example, my trunk was about 62 pounds, and they said that was normal. Right and left arms are normal. And then my right and left legs were both over. That means that I have too much muscle mass in my left and right legs. I cycled a lot, so that was really all I did as far as any kind of exercise was just cycling or running. So my left leg and my right leg had too much muscle mass. Let's see, further over here, they have my BMR. It's about 1722 calories, right? Remember the basal metabolic rate? That's your basic amount of calories that you need to take in order to just survive. So if you just sat around on the couch all day, that's how many calories you'd need to eat. Um, Now, that was in September of 2014, and then after that, I started lifting weights because I had some injuries and I was just had some back issues and leg issues and all sorts of issues. So I started lifting weights over in the gym, And a lot of this changed. So if you remember, first of all, my weight went up. It was at 163. It's gone up another 10 pounds or so from then. But whereas before, my dry lean mass, let me pull it up. Before my dry lean mass was 36 pounds. After, it was 38 pounds. So it went up a little bit. Um, my skeletal muscle mass went up quite a bit. It was 83 there. That's in September, or excuse me, in May. Here it was 78 pounds. So it went up about 5 or 6 pounds. The interesting thing here is that if you look at oh, that's September, sorry. So this was back in September, sort of pre-weight training. And then this is in May. So now my left and right legs were normal because I hadn't been cycling and basically sort of stopped doing that. I gained weight basically, but now my left and right arms were over and my trunk was also over. So it can give you a good analysis of sort of where you are in your physical body, like what you need to train on and where you're stronger and where you're weaker. Also notice my BMR, it was about 1700. It went up to about 1800. And about that time, I think I've told you this, like when I started lifting weights, it's just I became really hot at night. I felt like I was always warm because my basal metabolic rate had gone up. And that happens when you build muscle mass. We'll try to take a look at it when we go over there. It sort of depends if they allow us. We can take a look. Maybe if you want to get your report, you can do so. Alrighty? Any questions about that? It's a pretty cool device. I think it can be pretty useful. Um, all right. Let's take a look at the nervous system, and then that'll be the very last part for this chapter. The nervous system uses nerve cells to transmit information. Through the flow of electric charge. So this is sort of the tie-in when we're talking about potential and resistance and current. Though your neurons don't work in exactly the same way as, say, a circuit when you have a battery hooked up to a light bulb, they don't work in exactly the same way. But they do have a lot of similarities, and so we'll try to point those out. The purpose of the nervous system have a couple purposes or several purposes. The first is sensory input. This just takes input from your surroundings and then also from your systems. So takes information from the surroundings. Right? This would be external stimuli, like you go outside and it's hot. It's like your nervous system will tell your brain, gosh, it's hot, you need to start sweating now. Takes information from the surroundings and then also from other organ systems. You start using your muscles a lot, it tells your heart to beat faster, that sort of thing. So it basically transfers information both internally and externally, external stimuli and internal stimuli. Takes in that sensory input. Second purpose of the nervous system is integration. And this is where it processes the sensory input and determines what to do in response. And then the third thing is the output or the motor output. And this is where the nervous system causes the body to respond. Nervous system causes the body to respond. You can probably think of lots of different examples where this acts, as I said, like the hot example. If you go outside and it's really hot, your body will take that sensory input and say, gosh, it's really hot out here. And then it will integrate this sensory input. We really got to do something about this. Maybe you need to ramp up your sweating or whatever. And then the motor output would be to start sweating. Or if you put your hand on a hot stove, you put your hand on the burner or whatever, and it sends the sensory input that you're burning your hand. It would integrate it in just a millisecond or less, saying that you need to do something about this, and then the motor response would be to actually jerk your hand away. So sometimes it's voluntary, sometimes it's involuntary. All right. So those are our three purposes. We have two main parts of the nervous system. May I go down from here, y'all? Yeah. All right. Two main parts: the central and the peripheral. The central nervous system. It's going to be like your brain and your spinal cord. And then also the peripheral nervous system. This is basically everything else. So you have sensors all throughout your body that determine temperature or heart rate or blood flow or whatever. So the peripheral nervous system is everything else. The peripheral nervous system, the PNS, we'll call the central nervous system the CNS. The PNS accomplishes the sensory input. The CNS does integration. So the central nervous system, decides what to do basically, and then the PNS will send the information for action is sent through the PNS. So just have an understanding that there are two parts of the nervous system, and then also what those two parts do. The central nervous system is largely just integration, that it decides what to do, and then the peripheral nervous input. The peripheral nervous does your input, and then it also sends the signal for whatever action is determined. I should have had this in anatomy, right? I'll cover the nervous systems probably in more depth. Yeah. All right. Okay, we have two types of nerve tissue. We'll look at the neuron and how they work. But we have two types of nerve tissue. Uh, Neurons and the support cells. The neurons actually transmit an electrical signal, while the support cells, these are also called the neuroglia. Is that how you say that? Y'all know? You have no idea? Then I will just say it with confidence. Neuroglia. The support cells, these basically just support the neurons in various ways. So like, for example, in the neurons, you have those myelin sheaths that cover that protect the what's it called, the axon, I think. For example, the myelin sheaths. We're going to mainly focus on the neurons, so don't worry about the support cells. We're just going to look at the neurons and how those work in order to transmit the electrical signal from one neuron to another. You may or may not have covered that. I'm not sure. You probably did in some sense in anatomy. But anyway, we'll look at the neurons and see how they work. Okay, so the neuron has several parts. You have a picture in your book. It has a cell body with dendrites and axons. In your book, there's a picture, I think, on page 161. If you want to follow along, I'll pull it up and show it on the screen too. But you have the cell body, the dendrites, and the axons. The cell body is the main part. And it controls the flow of electrical signals. Let me show you a picture, which you also have in your book. Listen, on the exam on Thursday, I'm going to have a picture of a neuron, and I'll ask you a series of identification questions. You can find similar questions in some of the old exams. Just make sure that you know the parts of the neuron. Similarly for the ear, right, because we also have waves and sound and hearing on this test. Make sure you know the parts of the ear, and not just be able to identify them, but know what the parts do. Because I might just ask you, what part does this? Transmits the electrical signal, for example, or controls the flow of electrical signals, and you would say, for that, you would say cell body. Pull up this. Yeah, so here's the neuron. This neuron is sort of common in a lot of different forms, but this is your stereotypical neuron or your prototypical neuron. Your cell body is this whole thing over here, this sort of central part, and it's sort of the brains of your neuron. It will transmit or basically send the electrical signals. We also have the dendrites, which are these little hair-like structures out here. The dendrites receive the electrical signal from another neuron. We have the axon, which is this whole thing right here. These are the myelin sheaths. They just cover the axon. The axon will transmit the signal to the next neuron. And we'll look particularly at how that electrical signal travels along this axon. So here we also have the axon terminals. These are just the ends of the axon. And these, of course, connect to the dendrites of another neuron, of the next neuron. All right, those are really the main parts that you need to know, what they do, and be able to identify them from a picture. It'll be a picture that looks a lot like this, or like the one in your book. Or if you want to see the actual picture, look online, and I'll show you one actually up on the screen. You need to know dendrites, the cell body, the axon, and the axon terminals. The axon terminals are just the end, the terminal end of the axon. All right, the dendrites receive a signal, the axons transmit the signal, and the cell body actually sends the signal, actually determines when a signal needs to be sent. The connections between neurons, so over here you would have another neuron that would connect to here. You'd have the dendrites. The connections between neurons are called synapses. This is just a connection between neurons. And that's it. Yeah. So know all those parts, be able to identify them, know what they do. Let's watch a little video of this is from the 2-minute neuroscience website. Have y'all seen it's sort of like 1-minute physics, which are y'all familiar with 1-minute physics? The physics 1 minute? No. Well, this is the 2-minute neuroscience. I guess neuroscience is more complicated than physics, so they need 2 minutes to describe it instead of one. Uh, but here in this little video, they just talk about the different parts of the nerve cell or the neuron. Take this away, y'all. All right. All right. So make sure you know those different parts of the neuron: the axon, the dendrite, the cell body, and well, that's it, right? Oh, and then also the synapses. The synapses are just those connections between the axons and the dendrites. So basically, you have this big, long string of neurons, and these neurons the electrical signal will travel along. If you have a strong enough electrical signal, will travel along these strings of neurons. All right, let's do a few clicker questions. We have a few. There. The synapses are the connections between the axons and the dendrites. Let's see, I think we've done these, right? The positive charge atom. We've done these about capacitors and stuff, do y'all recall? We have done, and this one too? Yes, okay. I consider this figure of a neuron. Which part of the neuron passes on an electrical signal to another neuron? Is it 1, 2, 3, or 4? And your test questions will look something similar to this. Which part of the neuron passes on an electrical signal to the next neuron, another neuron? All right, we'll stop at 35. 35. Okay, good. D is right. 4. Yeah, some of you put C. That's sort of correct, but the actual part that passes it on is the axon terminals, I think we call them, the end of the axon. We can think of the signal actually traveling along this, and the electrical signal does travel along the axon, but it's really out here where they're passed on those little tentacles that come out, and those actually connect in the synapses with the dendrites of the next neuron. Which part of the neuron controls the electrical signal that passes through the neuron? So what actually controls the signal that goes through the neuron, the electrical signal? All right, I'll stop at 28. Okay, good. He is right. Hey, what does a dog say after a long day at work? Rough. All right. Um, consider this figure. Which part of the neuron is called what is called the dendrite? Which of these is called the dendrite? 1, 2, 3, or 4? I'll stop at 18, 17, 18. Let's see. I think we have one other one maybe. Oh no, we'll come back to this. Alrighty. Okay, so those are your different parts of the neuron. Um, You have different types of neurons. You have three classes of neurons. Uh, Three classes of neurons. You have first sensory neurons. These conduct input signals to the central nervous system. So they're part of the peripheral nervous system, and they conduct these input signals to the central nervous system. And these account for our five senses: touch, smell, vision. We have motor neurons. These conduct central nervous system signals to the effector organs. When I say effector organs, I mean organs that actually will cause some effect or cause some change in your body. These can mean muscles, right, that you can send a signal to actually change what you're doing. But it can also mean glands and stuff that actually change your body chemistry. So muscles and glands are effector organs. They actually cause an effect in our body. And then the third class of neurons are interneurons. I don't know exactly what these are. Your book just said that they were in between sensory and motor neurons. I assume that that means that they actually work to transmit signals in between sensory and motor. But I don't know. Do y'all know? I'm trying to learn about anatomy right now, but it's kind of dense. Does anybody know what the interneurons do exactly? Okay, I'm not going to ask you about it on the test, but you do need to know sensory and motor neurons. Okay, um, let's look at the electrical properties of the neuron. This can be a little complex, and in fact, the chemistry and the physics of your neuron is quite complex. I think your book does a decent job of explaining it, but it can be fairly complex. So, we talk about sort of a circuit, like for example, if we have a circuit, we have charges, electrons that will move through the circuit, and they move straight through the wire, and they move through the resistors, and they move in a very direct path. But that's not the way it is with a neuron. You do get a transfer of charge, very much as you do in a circuit, but it happens a lot more differently. So we don't get, uh, charges don't move like in a wire, in a neuron. Instead, ions will move across the cell membrane. So if you imagine your axon here, this is the inside, this is the outside, this is the cell membrane. You'll have ions that will move back and forth. You'll have positive and negative particles that will move back and forth between the cell membrane, and they'll cause a difference in potential between these two parts, the outside and the inside. So for example, if I have a bunch of positive charges out here and a bunch of negative charges in here, inside the axon, I'm going to have what type of potential, a negative or a positive potential? If I have positive charges, negative charges, what kind of potential will I have inside the axon if I have a bunch of negative charges inside of it? will have a positive or a negative potential. If I have negative charges inside the axon, I have a negative potential because negative charges have a negative potential. And so they'll transfer charges back and forth, and we'll look at the processes by which they transfer these charges, causing a difference in potential between the inside and the outside of the cell membrane. And then this change in potential will sort of propagate down through the entire membrane. We'll watch a video here in a few minutes that shows how this happens. But it's not the same. The point here is that it's not the same as electricity flowing through a wire. Let's look at membrane potential. There's a figure in your book on page 163 about the membrane, the cell membrane. It gives a cross-sectional view and a side view of the axon. I'll just draw it up here in case you don't have your book. So this is your axon, the cross-sectional view. You have sodium ions out here, chlorine ions out here as well, and then you have some potassium cations that are positively charged, and then you also have these organic anions that are inside and outside the membrane. And if you look at the side view of your axon, your axon is sort of this long cylindrical thing in between the cell body and the axon terminals. You have these negative particles, negative anions, positive potassium atoms, and then you have sodium and chlorine. Now, you have different processes that cause these things to move in and out. Typically, you have more potassium ions inside than out, and you have more sodium ions outside than you do on the inside. So as we've drawn it here, you have sodium ions that are all throughout the system, but typically you have more sodium ions outside of the system than you have inside of the axon. And similarly, you have more potassium ions that are inside than you do have outside. You have a permeability in the cell wall. When I talk about permeability, it just means the ability for things to transfer across the cell wall. So these potassium ions and these sodium ions can move back and forth between the cell wall, but they move back and forth at different rates. So the permeability of the cell wall is different for potassium and sodium. These cations, these potassium and sodium cations. And because of that, more potassium ions will move out. More potassium ions will move out than sodium ions will move in. Right, so if we think about our axon, we have these sodium ions that are out here. We have these potassium ions that are out here. We're going to have more of these moving out than we have these moving in. So that'll give us what type of potential on the inside of the axon typically. If I have a lot of these potassium ions moving out and just a few of these sodium ions moving in, what kind of potential will I get, a positive or a negative potential? What now? I get a negative potential, that's right. So because of this, we get a negative potential. We get, fewer positive charges out than in. Or excuse me, fewer positive charges on the inside of the axon. So the potential inside the cell is negative. this is going to be, we'll call this the membrane potential. Membrane potential. We also call it the resting potential. It's sort of the typical state of our cell body, that it's always, typically when it's just sitting there and not transferring any information, the inside of that sheath, the axon that's covered by this myelin sheath, is going to have a negative potential. Typically this is about negative 70 millivolts. It's going to be about negative 70 millivolts. Now, if you have, I think that we'll skip the different mechanisms. We're not going to do that for the test coming up. There are different mechanisms that cause the ions to move in and out. But I think as long as you just know that you have more positive charges outside than you have inside, then you'll be good to go. So it gives you a negative potential on the inside. You probably talked about this in your class about how the different in your anatomy class, how the different ions can move in and out. Did y'all do this? The ATP and all that stuff? Yeah. We're not going to get into it here, so don't worry about that for the test coming up on Thursday. All right, but just know that our resting membrane potential, which is due to these different charges moving in and out, has a negative potential when it's just sitting there. Now let's watch this little video about the membrane potential. All right, so that's our membrane potential, our resting potential. I think on your quiz you had a question about that, right? I showed you the graph and you had to identify either the membrane potential, the threshold potential, or the action potential. I would expect something similar for the test coming up soon. I'll show you that again. Let's look at the action potential. The action potential occurs when you have some stimulus that stimulates the sensory input neurons, and then they send this electrical signal, the action potential. So when you have a stimulus in the neuron, causes ions to move across. The cell wall. And this changes our membrane potential. We can have two situations. Two situations. We can have graded potentials and action potentials. And we're going to look at the action potentials. It's sort of the change or the transfer of this electrical signal that occurs more rapidly. When you have this strong stimulus for the action potential, the membrane potential, or the potential of the cell wall, or the potential inside the cell rather, goes from minus 70 to about 30 millivolts. Because it allows these ions to move across, so you get this major influx of positive ions that will move into the cell wall, causing that potential to go from negative 70 up to about positive 30 millivolts. And then when you have this inside your cell wall, like if you imagine that this is your axon, what happens is you have this big influx of positive ions, and this part goes from minus 70 up to positive 30, and then it's like it prompts further ions as we move along the axon to propagate into the cell. So when I get this action potential, where it goes from minus 70 to positive 30, it occurs on this end, and then it moves down. It sort of propagates down the cell. It prompts the next portion. You have these ions that will move in, and then they continue moving in all along the way. So this action potential propagates along the cell wall as these ions move into the axon. Okay? That's called your action potential. Um, this occurs where you have to have a strong stimulus. This occurs, the action potential, when the membrane potential exceeds a certain value, and we call that the threshold potential. You can still get propagation of information even if you don't exceed this threshold potential. Your book talks about it a little bit, but we're not going to get into it here, and you won't see it on the test. And that's that graded potential. It's sort of a slower transfer of information, but when your body wants to send a signal very quickly, you have this action potential that comes into play. The membrane potential, of course, is minus 70 millivolts. This threshold potential is typically, about minus 50 millivolts. So it goes from about minus 70 to minus 50, and then you'll get a quick rise in the action potential and causes that propagation of this electrical signal along the neuron. I have another video I want to show you, another one of those 2-minute videos that describes this. And your book, I think, oh no, they don't have a picture. Well, let me show you this. All right, let's do this top one. I have this plot. It shows membrane potential versus time. The point at 30 millivolts is known as what? That point at plus 30 millivolts. What is it known as? All right, we'll stop at, say, 35. 35. What is the 30 millivolt potential? Okay, awesome. That is your action potential. So looking at this graph, like they showed in the video, uh, oh, that was you? Okay. Everything okay? Oh, okay. All right, so this is plus 30 millivolts. This is our action potential. Notice it's right here. This is our action. And then how about this next question? The point at minus 70 millivolts is known as what? All right, I'll stop at 25. 25. Okay, very good. D is right. Yeah, D is right. Is minus 70. This is our resting potential, or our membrane, or resting potential, or membrane potential. If your neuron's not doing anything, that's what it is. So it's usually at minus 70. And the threshold potential is right here. All right, so when you get a stimulus, it causes a change in how the ions move across the cell wall, causing an influx of positive ions, making this minus 70 jump up. If it gets up to, if it's enough to jump up to minus 55, that means the stimulus is enough to further go on and create this plus 30 millivolt. And this is this action potential which travels very quickly across the axon. Okay? Is that as exciting as y'all look? Okay. All right. Well, you will see it on the test. You'll need to know the basic parts of the neuron, basic ideas of how it works. Again, don't worry about the depolarization, all that jazz. Don't worry about graded potentials. It is in your book, and it's interesting, but we won't see it on the test. I think that's it for that chapter. Yeah, that is it. Okay. Okay, well, let's do this. We're not going to move on to the next chapter, but I do want you to do this. I want you to take a sheet of paper. Well, first, a couple of things I want to talk about. Uh, I usually do midterm assessments. That is where you can say, this isn't really working for this course. I need this to be changed. I'd love for this to be changed, that sort of thing. You'll do assessments at the end of the semester, but you know that won't impact you. So take out a sheet of paper and don't write your name on it, and just write one thing that you like and one thing that you would change about the course. One thing that you like and one thing that you would change about it. All right. Um, Then you'll also need a second sheet of paper, and on that I do want you to write your name and write in one sentence or so the idea that you have for your project. Yeah, that's fine. If you want to tear it in half, that's fine. So I'm not going to grade it or anything. You're not even locked into that idea, but I just want to get a feel for sort of what y'all are thinking about ideas for the project. Okay? And then another thing I just want to sort of throw out there, some of you have benefited because last year I bought the books from students before they return them to the bookstore. Does anybody know how much you get for these when you return them to the bookstore? About? You get $10. So you get what? $5 to $10 back for them? Does anybody know? Okay. I'll give you some amount. If you wish to not sell it back to the bookstore, I'll purchase it for some amount. Probably it's going to be $7 or $8. I have to see how much money I have. And then the purpose of that is I'm sort of building a library so that students who take this next spring, they won't have to buy the book. They'll just borrow them from me. And about 15 of you actually benefited from that this semester. I know some of you did buy your book because it was first come, first serve. But I hope to have enough books for everybody next year. Okay? So just sort of keep that in mind as you're getting ready to wind down in the course. Okay, so do this, the assessment, one thing you like, one thing you'd change, and then also an idea for your project on a separate sheet of paper.